Lecture name is a linear equation in one variable. We are going to explore it as much as I can explain it with you. I will be explaining. At the end of this lecture, you will have knowledge regarding this lecture. Remember, our focus will be on concept of this lecture, not on questions. Some questions we will be taking as examples. Uh, yes, full focus. Our full focus will be on understanding of concepts. Uh, it is more important to understand concept very well. Let's start. We have this equation. We are starting with this word. This word will tell you what is a lecture. Of what is a lecture? Equation which means equal. When we apply equal, so we apply equal, a equal, then in left side this equal would be one side and the right side of the equal would be a right side. In both sides we can apply quantities, and when we will apply quantities in both sides, so remember here you applied equal, so here you are saying both sides, but whatever number are in both sides, both are equal to each other. That is what you are saying by applying equal which means equal. 2 plus 5 is equal to 5 plus 2, both are equal in both sides. Now we have this uh, equation. We have equation, a mathematical expression that states that two quantities are equal. Two quantities. With example, let's try to understand. Yes, equation we will apply equal. Without this equal, equation is incomplete. Equation would be incomplete. Next we have example. To it would be more better to understand the meaning of equation with example. Here 2 plus x is equal to 8. Here we have two quantities. Here we have two quantities. This is side and this is side. This here we have two numbers. Here we have one number. In both sides we have two numbers. And remember, this side would be left side. This side would be right side. We go to two sides because of we applied this equal sign. That's why. Now here we are saying this side, whatever would be sum of this would be equal to this. This side is a 10, so sum of this would be 10, 10, 10. If this is a 9 and this is a 2 plus 8, then here we will apply this like that a slash, so that we can represent a not equal to. Here we will say 2 plus 8 is not equal to 9, so just we will have to apply a slash over the equal. Here as we know that this sum of this is equal to 10, that's why this equal came. That's why this equal came. Now next example we have 10 minus 5 is equal to 5. Here 10 minus 5, this side is equal to this side. This after solving this, here we will get 5 and this is already 5, so both sides are same. This is what is the meaning of an equation which means we take numbers in both sides, and both sides if are equal, then we will call that equation, we will call that as a equation. Now linear equation in one variable, this is the main point for this lecture. Linear equation which means here let's say variable. Here we will take one variable is just alphabet. A letter we will take, so how much? One letter we will take. Equation, it is an equation that can be written in the form of this ax plus b is equal to 3. Here remember, a would be something here, this is a number also, but x is not number, it is a unknown number. B would be constant number. C is also constant number. Any number which is with not with variable would be constant number. Constant number. Ax is equal to b. Here a is not a constant number. In details we will explore about constant variable. Here variable is just alphabet. We apply alphabet number, so that because we don't know, for unknown number we apply alphabet. We apply a variable for unknown number. At the end we will get a value of unknown number. We apply a variable because we don't know unknown number, that's why. Ax plus b is equal to 3. This is how we represent linear equation in one variable. Remember, here you have linear equation. Linear which means exponent should be 1. Linear which means exponent should be 1. Here linear of exponent of this variable is how much? 1. 1 is always hidden. 1 is always hidden. And here this linear equation is in one variable. Here we have only one alphabet, that's why this is this is a linear equation in one variable. If we take a y also, then this 1 and this y would be what? Both are two variables, so we will say linear equation in two variables. But right now we have one variable, that's why we are calling it as a linear equation in one variable, where a, b, c are constant and a, so indirectly you can say a is a constant but not coefficient. A is a coefficient number. Any number which is with variable will be considered as a coefficient number. Any number which is with a variable will be coefficient number. Any number which is not with a any number which is not with a variable will be what? Constant number. As you can see here, x is a variable and this is a with this number. This is what? Is a coefficient number. Now b is a exact number. It is not with a variable, that's why this will be constant number. Now here, and a, hold on, what happened? A 3x plus 9. In this case, you can say, let's identify a constant number, a coefficient number, and a variable. So here, there's a 3. 3 is with variable, so 3 would be coefficient. X is a variable. It is alphabet. It is a variable. Now we have addition. It is operator. Operators are what? Subtraction, multiplication, division, addition. These are mathematics. These are operators of mathematics. We use these operators so that a equation can make. Here 9 is a exact number. It is not with a variable. That's why this would be a constant number. A constant number is a number which is fixed. It does not change itself after taking many steps. But here a coefficient which is with a variable will change itself after taking many steps. X is a clear unfixed number. But here this 9 0, it is a completely fixed number. That's why any number which is a completely fixed number is called as a constant number. Same here, 7 is with a variable. 7 would be coefficient. X is a variable, plus is operator. 5 is a constant number, equal. This is how we represent the equation. 2 is a coefficient, x is a variable, minus is a operator, 9 is a constant. Now next we have, here you can see 4. After solving this, you will be able to identify coefficient, constant, and variable. Here from this, 4 is what? 4. First of all, you will have to solve this. 4x minus 4 to z. So this would be what? 2 would be constant number. X, this 4x would be 4 is a coefficient, x is a variable, 6 is a constant number. X is equal to 6. So x, here x is what? Constant number. Here linear equation. What about linear? In this x, just to look at x variable. Just look at x variable. How much exponents are of x variable? Of course, there is nothing. So this here is one hidden. Always remember, one would be always hidden. So there is a one exponent, and one exponent is a what linear equation. Second would be quadratic, third would be cubic. Linear equation is equal to first degree equation. Yes, first degree. Exponent should be 1 for a linear equation. To represent a linear equation, degree should be 1. Exponent should be 1. First degree because the highest powers on the variable is 1. Solution. The value that can be substituted for the unknown variable, so the result statement is true. Yes, this would be solution. A linear equation would be solution. It has many solutions. Solution set, the set of all solutions. Yes, it has all solutions because of we have linear equation. Linear equation has all solutions. Used to show solution set. To determine it, a value is a solution. To determine if a value is a solution, then substitute the value in for the unknown variable. Just we will have to put the value in place of a x variable, in place of a variable. Then we will get a solution. Simplify both sides of the equation. Both sides just simplify. After solving this, you will get exact value of x. Then just okay. Does it make a true statement? Both sides of the equation are equal. If both sides are equal, then okay, till here this is a right. If yes, then the value is a solution. If not, then value is a not solution. Both sides are equal to each other, then value is a solution. If no, then the value is not a solution. For example, with example, example 4 is a solution to 3x minus 5 is equal to 5. After solving this, we should have x as a 4. So let's just say 3x is equal to 7 minus 7 plus 5. So 12 upon 3. Of course, this is a solution. Both sides are equal. So that's why this is a solution. 3x minus 5 is equal to 5. After simplifying both the sides, we will get a solution. Here we are putting 4 in place of a variable. Now after substituting the value of a 4 in this given equation, at the end if you are getting both equally, then you can say this is a 4 is a solution to this equation. Yes, you will get both equal. True statement. Next, in this case, let's see what will happen. 2 is not a solution. It is already telling me that 2 is not solution, but you have to prove that yes, 2 is not a solution. Let's prove it. Here remember, we are going to substitute this 2 value in the place of a x variable in this equation. 5 2 are 10. 10 minus 9, 1 is equal to 6. Both are not equal. That's why this is not a solution. 2 is not a solution to this equation, for this equation. Here you can say 5 2 are 10, and here 1 minus 6 you are getting. 1 is not equal to 6, so it is not solution. 2 is not solution. We are saying 2 is not a solution to this equation, for this equation, so false statement. Next we have determine if the numbers are solutions to the following equations. We got this, it is what, it is a value of a variable 1 upon 2. So 1 upon 2 we will substitute this value in place of this variable 1 upon 2, then 2 will cut 2, 2 will cut 2, then 1 plus 5, we got 1 plus 5, so 1 plus 5 6, 6 is equal to 4. So of course both sides are not equal, so we will say 1 upon 2 is not a solution for this equation. What about this example? We have a 3, we are going to substitute the value of this 3 in this variable, in this variable, and as well in this variable. So 4 3 is 12 plus 3, so 4 3 is 12 plus 3, 15, 15, 12 3 15, okay. 18 minus 3 would be what, 15, 15. So both are equal, both are equal. So here we will say that 3 is a solution for this equation. 3 is a solution for this equation. Let's see how to solve linear equation. To isolate the variable on one side. Remember, I have told you that this 1 upon 2 is not solution for this, and 3 is a solution for this. You can observe, you can see it through yourself by solving this. Now next, how to solve a linear equation. Associate the variable on one side of the equation so that the number that is the solution is on the other side. Associate. Typically variable left hand side. Whatever you have a variable in both sides, just to shift all variables in one side and all constant numbers in one side, then simplify this, you will get a answer. Solution right hand side, variable left hand side, variable should be left hand side and solution should be right hand side. It is a choice, it is a choice. It would be standard. If you do like that, then it would be standard. Next we have, but it does not matter which side is which. Yes, it doesn't matter. You can shift this in a right side, you can shift this in a left side, but this is a standard. If you do like that, then you will not get confused. Think of sine as a scale that keeps everything balanced. This is a balance. What do you do one side, you must do to the other in order to keep the equation balanced. If you keep here one book, you have two book which mass is equal. If you keep one book in this, then what will happen? This would be unbalanced. This is empty, and here you put a book. What will happen? This will come downward. It will tell you that this is a this has a more mass. But when you will keep another book on this, then what will happen? Both will be equal. This is how it works. To isolate the variables, use inverse operation. Inverse operation, which means operations. If you take a plus, then you will have to take a minus. If you have a minus, then you will have to take a plus. Opposite of a plus would be negative. Opposite of a multiple would be division. Opposite of a division would be division, multiplication. Inverse operation that undo each other. Addition and subtraction are inverse operation, and multiplication and division are inverse operation. Opposite of this would be division, opposite of this would be multiplication. Opposite of addition would be subtraction, opposite of subtraction would be addition. These are inverse operations, and this will help us in solving equations. if in one side, if we have a algebraic in one side, inside, if we have numbers in one side with operators, for example 2 plus 5, then just if we wanted to convert, if we wanted to shift a one term which is in the left side into another side, then we will have to convert this plus into minus. When we are shifting a term from one side into another side, then you will have to convert sign operators. Let's see steps to solve a linear equation. Simplify both sides of the equation as much as possible. Simplify. Just you should have a simple equation after simplifying. Clear fraction, combine like terms, use the distributive property. 3 x plus 5. Move all variables terms to one side of the equation and all constant terms to the other side. Constant terms should be in other side, variables should be in other side. This is what simple. This is simple equation. Variables left side of the equation, constant right side of the equation. Use addition or subtraction to opposite of what is given. Isolate a variable, make the coefficient 1 on one side of the equation and the solution on the other side. Use a multiplication or a division to opposite of what is given. If you given multiplication, if you want to shift a term which is in a side into another side, then just you will have to convert the multiplication into division. That is how you will do. This slide is done. What happened? Okay, this is done. Now next chapter let's explore. Now let's explore next chapter. Next we have understanding quadrilaterals. Understanding quadrilaterals. What happened? Allowed content is protected. Practically geometry. This is a PDF. Now let's explore this. We have practical geometry. Practical geometry. We have learned how to draw triangles in early classes. For this, we required three measurements to draw a unique triangle. Since three measurements were enough to draw a triangle, now natural question arise whether four measurements would be sufficient to draw a unique four-sided closed figure, namely a quadrilateral. We have to focus only the construction of a quadrilateral like figure. We are going to explore what is a quadrilateral. What is a quadrilateral? Constructing a quadrilateral. We shall learn we shall learn how to construct a unique quadrilateral given the following measurement. When four sides, you should have four sides, four line segment, four vertex, four angles, four integer angles, two diagonals. When four sides and one diagonal are given, then we can construct a quadrilateral figure. When three sides and two diagonals are given, when two adjacent sides when two adjacent sides and three angles are given, when three sides and two included angles are given, whether other special properties are given, when other special properties are given. Let us now we discuss three constructions one by one. When the lengths of four sides and a diagonal are given, we have this four, 1, 2, 3, 4. With the help of a above information, the quadrilateral can be constructed by taking an example of a definite measurements as construct a quadrilateral PQRS. For example, PQRS. How to draw a figure of a quadrilateral? Just you should have four sides. Just you can put like that four sides. And here we can observe this vertex, this vertex, this vertex, this vertex. Finally, we have four vertex. So this is line segment. This is also line segment, line segment, line segment. So total we have four line segment. Inside this is known as interior angles. This is known as interior angles. This is interior, and outside of this is exterior angle. In this we have four interior angles, and in this we have one diagonal as well. Construct a quadrilateral PQRS. Here PQ is 4 centimeter. Measure of PQ is 4 centimeter, and QR is 6 centimeter, and RS is 5 centimeter, and PS is 5.5 centimeter, and PR should be what it should be a diagonal. It should be diagonal. PR is 7 centimeter. This is how we measure a line segments of a quadrilateral. And length of sides can be more, can be less. It doesn't matter. Now construction. First we draw a line segment PR of 7 centimeter from point P and R. Make 2 R. From here, uh, from here, from here to till here. This is 7 centimeter. 2 R's of measurement of 4 centimeter and 6 centimeter. Joining a point QS, PQ and Q as a PQ and PR. Just we will take two more line segment, PQ and PR, PQ and PR. Again from point P and R, making two another arcs of measurement 5.5 and 5 centimeter as intersecting points. S intersecting point should be S. Here should be S. This will be intersecting point. Join PS and RS. This is the final construction of a quadrilateral PQRS. When three sides and two diagonals, three sides and two diagonals are given. Construct a quadrilateral ABCD given that BC is 4.5 centimeter and 5 AB is 5.5 centimeter, CD is 5 centimeter. Okay, AB, BC, CD, DA. What about DA? So diagonal is AC is equal to 5.5 centimeter and BD is 7 centimeter. These are measurement of diagonals. First we draw a diagonal AC 5.5 centimeter. This is 5 centimeter. From points A, C draw two arcs. A, C draw two arcs. As in draw two arcs from point. In this you are following. What is a rhombus? What is a rhombus? What is a rhombus? Rhombus is also it is also quadrilateral. But here draw a rhombus whose diagonal AC and DB are 7 centimeter and 6 centimeter respectively. Here construction. For the construction of a rhombus we have to draw a two diagonals AC and DB of a definite measurement intersecting at a right angle to each other. Here would be uh, what this is not a right angle. This is not making a right angle. Now join AB, BC, CD and DA. This is the complete rhombus ABCD. Here this is not a right angle. Even I do not understand practically geometry, but we can ignore it. I was going to explore this understanding quadrilateral, but it is not working. Right now, it is not working. Now, next we have data handling. Next we have data handling. I think it should be enjoyable. Data handling. How to manage a data handling. How to handle a data. This is all about the data. My understanding this lecture, you will have you will have understanding of data handling. It will help an understanding of handling Excel. It will help you in Excel. When you will be learning Excel, then this will be useful for you. There are a lot of uses of data handling, not only Excel. This is a basic. This is pure basic about this data. Let's start. First of all, let's see how much number of slides we have in this. Number of slides we have in this. So let's see. We have this much. So 21. We have 21. No problem. Let's start with the second slide. Data handling. Data handling means to collect and present the data so that it could be used in further study and to find some result. Yes, data handling, which means when we collect information and we want to represent, we represent that collection of information, collection of a data, collection of a something, uh, and we represent that data so that anyone can interact with that data. We will take a raw collection of something, raw collection of something, collection of raw materials. Then in our way we will represent that collection of something. In our way we will represent, and here main point would be what we will have to represent so that anyone can interact, so that anyone can understand what are we trying to tell to public. Okay, by representing data. Okay, in this you will have information, you will have collection of something, collection of books, collection of shops, collection of shopkeepers, collection of houses. There are a lot of things, there are a lot of things, and here there are a lot of people who manage a shopkeeper, who manage information regarding clothes in mall. So this becomes possible when they use Excel, when they use a technology. And technology, they use a technology so that they can handle data. So what is the meaning of a data handling? I hope you are clear. This is just a collection. We collect the information and then we represent that information, uh, so that I can interact with my data. Okay. Raw material would be just a original data, and after after representing raw material, we will call it as a grouped data. Let's see next. Data, a collection of information in the form of numerical figures, is called a data. This is a standard meaning of data. So a collection of information in the form of numericals. We take some visual. We represent a collection of information by visuals, by numbers. We represent. Yes, we will have numbers. We will have visuals. Through visual, public will be able to understand, will be able to interact with our information. Example, marks of 5 student of a class, this is how much? This marks of 5 student, marks of 5 student are this much, this much. So this is how data can be represented. Now raw data is just, what is the raw data? It is just original data, original data. We didn't do anything with the original data. Is a what? Raw data is just raw data. If we do something, if we apply something on a raw data, will be called grouped data. When information is collected and represented randomly, then it is called raw data. Example, height of 5 students of a class. These are as follows: 128 centimeter, 124 centimeter. These are heights of a 5 student. This is what is a raw data. It was used. It was given this collection of This collection of this information was given randomly. This is what raw data. It will be known as raw data. Now next we have arranging the raw data. Arranging the raw data. Raw data, we have this raw data 29, 32, 31. These are, it looks complicated to understand it. So after arranging this raw data, we arranged this in this way 21, 22, 23. It is about ascending order. Now it is very readable. We can read this. Here we can say yes, first number is coming 21, 22, 23. This is what is a readable. This is not a readable. Yes, anyone cannot interact with this number. Now anyone can interact with this number, and that person would say yes, this is a ascending number. Now this was a raw material. Now this is a ascending. This became ascending order. This became ascending order. Now we will say this is not a raw material, a raw data. Now next we have organized data. Organizing data. Usually data available to us is in a unorganized form called raw data. Unorganized data is just raw data. To draw meaningful inference, we need to organize the data systematically. For example, a group of students was asked for their favorite subject. The results were as listed below: art, mathematics, science, English. Here we have a number of students, and these are these are names of subject: science, English, mathematics, art, English, mathematics, English, again English, art, science, again art, science. It is a very complicated. We are not able to understand. We are not confirmed that what is it saying. So this is not readable. We will make it readable. We will make it readable so that you can understand, anyone can understand. This unorganized data. This is what is unorganized data. This is the raw material, which is the most liked subject and the listed like. Here question is which one subject is the most liked subject. So of course a subject which is a subject which is coming more times will be more liked and the one least liked, and a subject which is coming less time will be less liked. Here we are not able, we will look here, then here, then here, then here. Sometimes it is just a small data, but what about if we have more data? Then we will get confused. That's why organizing the data is important. We will group it. We will say this is art in this is art in this. You will get art subject. In art subject you will get yes, art, then science, English, mathematics. Somehow we will organize it. Let's see. Frequency tells us the number of atoms. For example, here what is happening? Frequency from this unorganized data we can understand. Here a art is coming how much times? A art is coming. This is 1, 2, 3, 4, 5, 6, 7 times. So it is a frequency. Frequency of art is, what is the frequency of art? You would say 7. We are saying 7. 7 is 7 frequency. So here we are trying to say that yes, number of art is coming 7 times. This is what we are saying. So what is the frequency? Frequency is the number of atoms. For example, mathematics. It is coming how much time? So mathematics 1, 2, 3, 4, 5. 5 times it is coming. So we would say frequency of a mathematics is 5 times. Now frequency tells us the number of the times a particular quantity repeats itself. The above sequence shows the number of the atoms times a particular subject repeat in a group. We saw that a number, a subject which is coming again and again, it is repeating itself. So this repeating would be frequency. Frequency can also be shown by the tally marks. A cut over four lines represent the number five. What? How does tally look? Like that, 1 2 3 4, and over this one slash, this is what 5. We will say tally marks, don't worry. Now here you will say tally marks. So finally this is what organized data, this is what grouped data. We are saying it is looking very readable in this visuals applied, visuals were applied. Here subject is, it is a heading, you can consider it as a heading. This is subject. In this we in this column, in this column we will get name of a subject. In this column we will get tally marks. In this subject we will get number of a student. Here 7 is a number of a student. 7 a student liked art, 5 a student liked mathematics, 6 a student liked science, 4 a student liked English. A student would like that. These are students. This much students like these subjects. The number of the above particular subject. The number of before particular. Each subject gives the number of this. Here, this is how we represent a number in tally marks form. This is how. So 1 2 3 4, over this 4 is a 1. So this would be considered as one number. So 4 1 5 5 to 7. This is how tally marks are represented. Frequency distribution. This was about frequency distribution. Here we are saying this art is coming 7 times. So 7 students liked this art. How much students? 7 students. And which one? So which one subject was like less? So of course this English is less. 4 people, 4 students who selected English, it is a less number as compared to this. Representation of a data. Representation of a data. For easy understanding and meaningful comparison, the raw data will be represented in the tabular form or pictorial form or a graphical form, and in many other forms will be represented. Tabular form, pictorial form, graphical form, all this we will cover, all this we will explore, don't worry. Raw material can be represented in the form of a tabular, pictorial, graphical. Let's see. We have a representation of a data. By daily chart you can represent a data. By frequency chart you can represent a data. By this pictograph, by bar graph, by double bar graph, by histogram, by bar chart, by circle. These are options. By this bar graph you can represent any data. We will visualize it, don't worry. With a pictogram, we take a pig, we represent pigs. When we represent the data through pictures or symbols, then it is called pictograph. Here we have name. These are names of fruit. Here number of trees. This is what. Here we are representing number of fruits with the help of a pig, with the help of a picture. Here we are saying apple. Tree of apple is how much? 3. Tree of a peach is 4 times. Tree of a guava is 2 to 5 times. Tree of a pear is 2 times. So this is how we can represent a data by showing figures. Okay, figures. So this is organized data. Here we are saying anybody can interact with this by saying that Yes, by this apple, this is a number of trees. So tree of a apple are three. Number of apple trees are three. This was about pictograph. This is what pictograph. Just we use what figure. If we are using figure, will be known as pictograph. Now next we have a bar graph. Bar graph will look like this. Just we apply rectangle over the we apply rectangle uh, over the on the graph. Here you can see in this bar graph the information represented by the bars of the same width with the equal gaps, but the height of the bar represented the representing value. This 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 is size would be more or less. It should be more or less so that we can understand what is it is saying. Here these gaps would be equal. These gaps would be equal, and this width would be equal, but height could be less, could be more. Here we are saying pet survey. This cat, how much cat? uh, five cats. Five cats. Here we have five cats. This is how you can say. Otherwise you can represent this data by using peak of a cat. You will have to represent five peak, then six peak, then three peak, like that. But it is also possible uh, to represent the data by bar graph. Here we are observing this bar graph. Here this is a rectangle is going till the 5. Here we are saying cat, number of a cat is a 5, number of a dog is a 7, number of a bird is a 3, number of a fish is a 4, number of a rabbit is a 8, and number of this hamster is a how much? 1. This is how you can represent any data by this bar graph. Bar graph, remember, bar graph will look like this. You can have more this rectangle according to data. According to data, don't apply unnecessary rectangles in your bar graph. Now next we have double bar graph. In this we have single bar graph. This is single rectangle. Now here we have a double bar graph. In this we are saying double bar graph. To compare some data, we can use the double bar graph, as it shows the information of two quantities. Here we are comparing two data. This is 50, this is 65. Double bar graph. Here marks. Here is Paul, Shina, Vanishta, Anjan, Johan, test 1, test 2. Oh, now I got it. It is telling you that this is a student. This is a student in first test. This student got this much marks. But in the next test, this student got 65 marks. Next this student Sinha, in first test, this he got how much? 45, 45 number. But in the next test he got 50 marks. Next is Vinista is a student. This she got. I am considering. I am assuming that Vinista is a girl. She got in first test how much? 60. But in the next test she got 70 numbers. Then Arjun. So Arjun got in first test how much? 65. In the next 80. Then we have Johan. In first test he got how much? 55. Then in the next test he got 65. This is how we understand. This is how we read any data which is in double bar graph. So here we are comparing. Yes, first student in first test got this much number, and in second test got this much number. So that's how, if you are comparing two things Then if you are comparing anything, you can represent like that those data in this form, double bar graph, the double bar graph. Next we have grouping data. Grouping data, if we have a large number of quantities, if you have a if you have a large number of a quantity, then we need to group the observation and then make the table. Such a table is called a grouped frequency distribution. It will help when you have a lot of quantities, then this will be useful for you grouping data. Let's see how does it look. How does it look? Some important terms related to grouped frequency distribution table: class interval or class interval or class. We will see what is it. When all the observations are classified in several groups according to their size, and then these groups are called class interval. Okay, just we are adding it. Lower class limit. The lower class in every class interval is known as its lowest number, not lowest number in every class interval is known as its lower class limit. Upper highest number, width or size or magnitude of the class interval. The difference between the upper class limit and the lower class limit is called the size of the class interval. What is a class interval? When all the observations are classified in several groups according to their size. So difference between a upper class and lower class limit would be what the size of the class interval. Let's visualize it. This was a theoretically. Let's visualize. This is what a histogram. This is a histogram. Histogram is also a way to represent data. Grouped data can be represented using histogram. Histogram is a type of a bar diagram where the class intervals are shown on the horizontal axis, and the height of the bar graph shows the frequency of the class interval. Also, there is no gap between the bar, as there is no gap between the class interval. It will look like this curved line. It will look a curved line. There would not be any kind of a gap in this histogram. Let's see. Here you can see we have rectangles, but among this you cannot observe any kind of a gap. This is what is a this is a histogram. This is a histogram. Here we are saying from here to till here 65. From here to till here in this how much height of a black cherry trees. Height of a black cherry trees is how much? 60, 65. It would be 60, between 60 and 65. The next is 60, 67. We can see twos. There are two trees whose size are how much? 60. It comes between 60 and 65. There are more two trees whose size is more than 60, which comes between 65 and 70. Next there are eight trees. There are eight trees, and eight size of eight trees are how much? It come between 70 and 75. Next we have a 20 between 25 and 80. 25 and 80. There are 10 trees whose size is how much? It comes between the size of 10 trees come between 25 and 80. 25 to 80. It could be 26. It could be 29. The next we have four trees. We have four trees whose size of the trees come between 80 and 85. Then we have two trees whose size is how much? 80. Whose size come between 80 and 85 and 90. 85 and 90. So this was about histogram. Now we are going to explore pie chart or circle graph. Pie chart looks like a circle, but a pie can be cut A pie chart or a pie graph is a spherical chart that uses pie slices. We can cut a circle to show relative size of the data. The chart is divided into sectors where each sector shows the relative size of each value. Let's visualize it. Pie chart question. Draw a pie chart. This is a question. We will represent this in pie chart. Here, the frequency spent by a child during a day. A school number of 6 hours. 6 hours. A child spent 6 hours in a school. A child spent 8 hours to sleep. Uh, in sleeping. Uh, Number of hours is how much? 2 hours. 2 hours a child spent in playing. Uh, 4 hours a child spent in studying, and this much hour in watching TV, and this much hour in other. So this is a question. Yeah, this is how this question can be represented in this. Here we are saying this much. This is a more. Here is a more. What? A school. This is a school. This is a number of hours. This is a number of hours. More number of hours. And then this is a less. Then this is a. And this is a less. Then less this. Then this. Then this. It is our TV. Here this would come TV. This would come a school. Like that we can understand. Here we have a figure. We have colors. This color is telling about what this TV. This color is about TV. Number of atoms, number of hours. Number of hours is over here, which is in percent, in a percentage. The central angles for various observation can be calculated as this. Can be calculated as this. This is a for you. Thank you. That is done.